Hello my friends, and welcome back to the Wow Machine channel. A breakthrough in metal processing has arrived with the integration of a new circular saw and robotic automation. This advanced system delivers up to 95% faster cutting performance, transforming round bar production. Capable of handling diameters up to 180 millimeters, it achieves exceptional precision with length tolerances. Where a 120 millimeter bar once took 6 minutes to cut, the new line completes the task in just 20 seconds. The result is not only shorter delivery times, but also consistent, high-quality finishes. Speed, accuracy, and reliability. This innovation redefines efficiency in modern metalworking. Prime turning revolutionizes machining wheel stubs by enabling all-directional turning in a single setup. When powered by the Coroturn Prime Twin tool holder, roughing and finishing operations combine without frequent tool changes, significantly boosting utilization. The twin holder accommodates both Coroturn Prime A-type and B-type inserts. B-type for heavy material removal, A-type for high-quality finishing. Modern multitask machines often suffer slow tool changeovers of 15 to 20 seconds. The twin holder design slashes that time while maintaining production flow. B-axis machining adds flexibility. Tools mounted at 45 degrees angles allow precise positioning, enabling access even in tight or complex workpiece geometries. Small entering angles create thin, wide chips that spread cutting forces and heat away from tool tips, improving tool life. Output improvements of over 50% have been documented when comparing prime turning with conventional turning methods. Millennium Rings is recognized as a pioneer in the manufacturing of seamless rolled rings, produced through advanced ring rolling technology. A wide range of seamless rolled rings is manufactured in carbon steel, low and high alloy steels, stainless steels, precipitation-hardened steels, and non-ferrous metals. Certified to ISO 9001-2015, committed to delivering products that meet international standards of quality and reliability. Fabrication is initiated by raw materials sourced exclusively from certified vendors. Each material is tested, sorted by color coding, and cut into blocks. These billets are heated using advanced induction technology before being shaped with MPM hammers and pressed on ring rolling machines capable of producing diameters up to 800 millimeters and thicknesses of 160 millimeters. Precision heat treatment is carried out in-house, with processes including normalizing, hardening, and quenching. CNC and VMC machining centers further enhance accuracy and consistency, while industry-standard testing equipment guarantees the reliability of each product. Its seamless rolled rings represent strength, precision, and engineering excellence. Krieger Barrels has built its reputation on precision, consistency, and time-tested techniques. At the heart of that reputation is their single-point cut rifling process, the method they insist on for every barrel they make. Every barrel begins with steel of specially specified quality. Whether stainless or chrome moly, each lot of raw steel is heat-treated, cryogenically treated, and rigorously tested to meet strict mechanical and metallurgical standards. After the barrel blank is reamed to establish its gross bore, the reamed barrel is pre-lapped to remove any tool marks or irregularities. Then the cut rifling begins. Using single-point cutters, the rifling grooves are cut one at a time. The cutter removes very small amounts of steel, on the order of 0.0001 inches per pass. Because the cuts are so fine, it takes many hundreds of passes to complete the rifling along the full length of the bore. After rifling, the barrel is finish-lapped, hand-lapped, to improve surface smoothness, especially in the direction a bullet will travel. The lapping reduces surface roughness under 16 micro-inch in many cases, so that fouling is minimized and cleaning is easier. Because of this method, Krieger barrels have nearly perfect concentricity between bore and groove, extremely uniform twist rates, and minimal internal stress. Importantly, they do not straighten barrels after rifling, a step many cheaper manufacturers take that can reintroduce stress. Krieger's cut rifling process is slow, painstaking, but built for match-grade accuracy, consistency, longevity, and superior finish. In the world of modern vehicle manufacturing, the demand for lightweight strength has made aluminum wheels the standard for performance, safety, and efficiency. At the heart of this production stands the automotive aluminum wheel automation line, developed by Kula Makina, a fully integrated system designed to maximize precision and productivity. The process begins with raw cast aluminum wheels entering the line, where advanced robotic arms and conveyors ensure seamless handling. Each wheel undergoes automated machining to achieve the required dimensions, with high-speed CNC systems performing drilling, milling, and cutting operations to exact tolerances. Kula Makina's automation ensures that every wheel meets strict automotive standards for balance, durability, and uniformity. Following machining, robotic inspection stations employ sensors and vision systems to detect the smallest deviations or surface imperfections. Any wheels outside specification are automatically separated, ensuring only flawless components continue downstream. Surface treatment and finishing are performed by automated blasting, coating, and painting systems, applying uniform protective layers that resist corrosion while delivering a smooth aesthetic finish. Robotic manipulators handle wheels throughout each stage, minimizing human contact, reducing contamination, and ensuring consistent quality. The line also integrates automated packaging and palletizing systems, preparing finished wheels for transport with speed and safety. From start to finish, the entire process is digitally controlled, with real-time monitoring, data collection, and smart diagnostics that allow operators to oversee production with maximum efficiency. Kula Makina's automation line not only raises productivity but also redefines reliability, delivering aluminum wheels that support the automotive industry's pursuit of strength, performance, and sustainability. The Hoffman wheel assembly line represents a state-of-the-art integration of precision machinery and automation for the complete production of automotive wheels. At its core is the automatic wheel assembly machine, type RMS Mount-G, which handles the mounting of tires onto rims with consistent accuracy. Once assembled, the wheels move to the tire inflation station, type RFGR, where controlled pressure ensures the tire achieves proper seating and uniform inflation. To optimize performance, the line includes the bead seat optimizer with radially arranged load wheel, type RSOLW, applying pressure to guarantee an ideal fit between rim and tire. Quality assurance is a key aspect of the process. The wheel uniformity measuring machine, type RGMRA, detects any structural or assembly-related imbalances, while the wheel balancing machine, type AWS RE12H2, corrects dynamic and static imbalances for smoother vehicle performance. Weight application is handled with flexibility. Operators can apply adhesive and two-piece weights manually, or an automatic robot system can perform the same task with higher speed and precision. Finally, every wheel undergoes verification through the wheel audit balancing machine, type AWS RE12K, ensuring compliance with strict automotive standards. By combining automated precision with manual adaptability, the Hoffman wheel assembly line delivers wheels that meet the highest demands of safety, comfort, and performance in the automotive industry. Dyrestål stands as a symbol of both tradition and innovation in the art of forging. With roots reaching back more than 4 centuries in the Remscheid region of Germany, the company has grown into one of Europe's largest private open-die forging mills, employing nearly 500 people and combining craftsmanship with cutting-edge technology. At the heart of operations lies an immense stock of 30,000 tons of raw material, covering more than 100 grades of carbon, alloyed, stainless, and austenitic steels. From the first step, cutting billets on over 20 band and circular saws, to the forging halls, precision is paramount. Shafts, bars, and blocks, sometimes weighing up to 35 tons, are cut to exact dimensions before being heated to over 100 degrees Celsius. Forging, the company's traditional core, is carried out on 9 massive steam hammers and hydraulic presses. Here, pieces weighing from a few kilograms to 35 tons are shaped with remarkable accuracy. Smaller forgings are still maneuvered by hand, while larger components are manipulated with electro-hydraulic systems. Open-die forging allows Dyrestål to tailor size and form, whether for single orders or series production. Ring rolling is another specialty. Pre-forged blanks are transformed into seamless rings up to 3.5 meters in diameter and 8 tons in weight. These rings, destined for gear wheels, bearings, or sprockets, achieve excellent grain flow and strength thanks to controlled rolling forces of 250 tons. Heat treatment unlocks the hidden qualities of steel. In 33 advanced furnaces, components undergo hardening, tempering, normalizing, and stress relief annealing at temperatures up to 250 degrees Celsius. These processes ensure the right balance of wear resistance, machinability, and toughness. Machining is handled in a 9,000 square meter workshop with CNC controlled systems capable of turning shafts up to 15 meters long or drilling holes over 4 meters deep. Whether carousel turning, milling, or boring, the facility delivers precision for the most complex geometries and heavy-duty applications. Quality assurance is integrated into every step. Dyrastol operates under ISO 9001 certification, inspecting parts to more than 4700 standards. Automated ultrasonic testing, spectrometric analysis, tensile and impact testing, and hardness checks guarantee reliability and full traceability of every forging. Supporting production is a 21-meter-high automated warehouse with space for nearly 3,000 pallets, ensuring just-in-time delivery. A fleet of company-owned trucks extends logistics flexibility, bringing finished components directly to customers. The applications of products span across industries. In wind energy, forgings become bearings and gearbox components for turbines onshore and offshore. In steel mills and mining, they are shaped into rollers, couplings, and hydraulic parts. In shipbuilding, forgings transform into rudder stocks, propeller shafts, and stern tubes. And in the energy sector, they become step shafts for turbines, generators, and compressors. The result is a portfolio of products trusted worldwide for their strength, reliability, and performance. Hull Longmore operates 2 world-class spiral pipe manufacturing plants with a combined capacity of 100,000 tons per year. The process begins as steel strip passes through an edge milling unit, where edges are ultrasonically inspected before being helically formed. Welding is carried out simultaneously from inside and outside by 5 electronically controlled heads, with precise alignment ensuring full weld integrity. A flux feed and recycling system maintains controlled temperature, humidity, and flow rate, while automated inspection systems examine both weld seams and pipe body for the smallest flaws. After cutting, pipes undergo slag cleaning, visual and dimensional checks, and ultrasonic testing of the ends. Hydrostatic testing follows to guarantee strength under pressure. Both facilities feature full-length, real-time radiographic inspection, achieving a weld factor of 1. Final steps include mechanical beveling and inspection, with joining options such as the patented rubber ring joint for lower-pressure pipelines. At Meyer Werft, the foundation of every ship is steel, transformed from raw material into floating marvels of engineering. Shipbuilding begins with design blueprints and strength calculations, translated into precise technical drawings. From here, steel construction takes shape. Individual plates, each measuring 3 by 10 meters, are joined into panels as large as 35 by 25 meters. Reinforced with beams and girders, these panels form the walls and structures of the ship. Dozens of such sections combine to create massive blocks, with each cruise ship requiring 50 to 80 of them. Innovation drives this process. Meyer Werft employs laser hybrid welding, a technique that fuses steel with unmatched speed and precision, ensuring superior weld seams. Steel plates, treated with corrosion protection, are cut, marked, and prepared using plasma torches. On the panel production line, automation ensures flawless alignment, monitored by cameras and optical systems. Profiles are mounted and tensioned with precision rollers, while jig frames allow the creation of curved or complex structures. In semi-automatic assembly, blocks are pre-fitted with pipes, cabling, and ventilation systems. Ultimately, around 30,000 tons of steel are transformed into a luxury cruise ship, a high-tech masterpiece ready to set sail. The modern CNC automatic wood lathe machine brings a new era of precision woodworking. Guided by advanced programming, it performs turning, grooving, and detailed shaping with speed and accuracy. Each cut is consistent, producing high-quality finishes. From furniture to decorative posts, this machine combines automation and craftsmanship, ensuring efficiency, reliability, and superior results in production. In modern furniture manufacturing, the process begins with precise metalworking, which forms the durable frame of chairs and tables. Steel tubes or bars are cut using plasma cutters or automated saws, then bent, welded, and polished to achieve accuracy and structural strength. Once the frame is completed, wooden components are introduced. Natural timber or engineered panels are cut and shaped by CNC routers, lathes, and sanding machines, ensuring smooth surfaces and perfect fit. Although machines handle most heavy tasks, the skilled hands of craftsmen remain essential during assembly, adjusting joints, and ensuring structural harmony. Afterward, surface finishing is applied, polishing, staining, or painting with automated spray systems, complemented by manual detailing for color consistency and durability. Finally, the furniture is upholstered with premium leather. Craftsmen carefully stretch, cut, and stitch the leather over foam padding, securing it tightly to the wooden and metal frame. This final stage adds both comfort and elegance. The combination of advanced machinery and traditional craftsmanship results in furniture that is strong, functional, and aesthetically refined. The hot wound spring process at Bet Spring Manufacturing begins with solid steel bars heated in a custom-designed furnace to over 1,700 degrees Fahrenheit, ensuring uniform temperature before coiling. Once heated, the bars pass through a coiler, where they are formed into springs, oil-quenched, and hardened for strength. Further treatments include shot peening, presetting, rigorous testing, and protective powder coating. Springs can also be customized with logos and boxed for delivery. These high-performance springs serve diverse industries, such as automotive, aerospace, construction, agriculture, oil and gas, mining, military, and trucking. At Horsberg & Scott, advanced heat treat and induction hardening processes ensure maximum durability for large-scale industrial gears. Using an Italian-built induction hardening system from the OTT group, the facility can handle external gears up to 5 meters, 205 inches, in diameter with a face width of 28 inches. The system also supports internal gear hardening, raising tooth hardness to 52 to 56 Rockwell C. This precise hardening process enhances wear resistance and extends service life, making it especially valuable for demanding applications. Horsberg & Scott's unique capability has proven vital in industries such as wind energy and heavy industrial gearing, where strength and reliability are critical. Creating reliable house connections in polyethylene piping networks requires precision, safety, and trust in proven technology. GF Piping Systems delivers this through its LGF Plus tapping saddles, designed for secure integration and long-term performance. The process begins with cleaning the pipe surface, ensuring no contaminants affect the fusion. The LGF tapping saddle is unpacked carefully, avoiding contact with the fusion zone, then mounted and tightened into position. Fusion parameters and traceability data are scanned via the QR code, linking directly to product documentation for guaranteed accuracy. Once the fusion begins, the operator supervises the process while the fusion zone is cleaned with Tunget Bay Cleaner. Next, the insertion depth is marked before unpacking and mounting the electrofusion coupler and ball valve. If mechanical stress or displacement is possible, a clamping tool ensures stability. Fusion indicators are checked and marked, verifying a complete and reliable bond. After closing the ball valve, the cutter is turned back to the upper stop, and the removed P-pipe section is confirmed in the cutter base. The screw cap is tightened by hand, the tapping point is marked, and finally, the extension spindle is mounted.